All right, Matt 2, here we go. We got lesson 6.2.3. We're going to do some shortest distance problems. Well, we're only going to do one shortest distance problem. Anyways, here's the deal. Laura needs some help. She's hooking up some speakers that she's going to set up above a 8-foot cabinet. And for some reason, she's not into symmetry. So she wants one of these speakers to be 6 foot up and the other speaker to be 4 foot up. And she wants to know where to put her sound system. And she has to connect to those speakers. And for some reason, speaker wire is really expensive because maybe, like, I don't know, she's using gold wire or maybe she's using diamond wire. I don't know. It's just a random problem made up so that we can do some math. So we want to place her sound system somewhere so that we can do wires to the two speakers. And we want the shortest distance because we want to use the least amount of wire for that. So there's a lot of different spots that we can put it on. You might be looking at it going, well, shouldn't it be the same? You know, for any wire that I use, shouldn't it still work no matter what I do? And we can kind of test that theory. Let's say that we decided to put the speaker system right here. So if we did the speaker system right there, well, one of our wires would go straight up. That'd be 6 feet. If we put the speaker system here, the other wire would have to travel from here to here. So that'd be a right triangle, which is kind of nice. So the other one would be a right triangle. And this would be 4 feet over here, and this would be 8 feet, because here's where the speaker is, or the sound system is. So this would be the length of the wire. So you could use the Pythagorean Theorem at this point. We could do 8 squared plus 4 squared equals c squared. So we get 64 plus 16 equals c squared. And then we get, what's that, 80 equals c squared. So c would be equal to, or the wire itself would be equal to the square root of 80. Now approximately on our calculator, that's almost 9, I think. So if I did the square root of 80 on my calculator, I would end up with 8.944. We'll just call it 8.9. So how much wire does she need in this situation? Where she needs 6 feet right here and then 8.9 feet going over here. Because this is where A would be, this is where B would be. So these are the two wires that she would need. So if I do 6 plus 8.9, it comes out to 14.9 feet of wire. All right, so if it doesn't matter where we place it, we can put it anywhere else and get the same number. So let's just go the other place over here. We're going to say, what if she put her speaker right underneath there? Well, she put it right underneath there. So here's A over here. So A is 6 feet up, and then this is 8. So here's where her speaker is. And then to go up to B, this would be the wire right here, and this would be 4 feet. So it's 4 feet of wire, and then we need to do the Pythagorean Theorem again. And, ooh, this is nice. This is a 6, 8, and then 10 triangle, because it's a 3, 4, 5, where everything's just multiplied by 2. So this is pretty easy. So this wire would be 10 feet. This wire would be 4 feet. So we'd get 10 plus 4 feet. So it's not the same. So if we placed it here, we ended up using about a foot more. So this is super expensive wire, remember? So we're going to use a foot more. So at that point, we would be saying, okay, so it looks like the closer I get to A, the more wire I'm using. And it looks like it's better to be closer to B. But where is the best spot? So there should maybe be a spot in here that's even better than the two that I've chosen. And we could just keep on plugging in stuff if we wanted to, like if that's what we were into. Like we could do a distance of 2 over here, a distance of 6, and make 2 right triangles and find the hypotenuses of those 2 right triangles. But I want to find the very best spot. And this is where similar triangles comes in. The best spot will be the spot where we have two similar triangles. So remember, similar triangles have the same scale factor. So this scale factor, comparing these two triangles, this would be 4 to 6. So the scale factor would be 2 over 3, basically. Well, I still need to know how far away these need to be. So let's go ahead and work that out in a different color here. All right, I want to know how far away from here this needs to be. So I'll call this part X. And then this part would be 8 feet minus whatever X is. So I'm going to call this 8 minus X. So at this point, we're going to do a proportion. So 4 over 6 is proportional to X over 8 minus X. Okay, we'll do cross products at this point. So 6 times X, let's reduce this first, 2/3. So let's do cross products, 3 times X is 3X. And then 2 times 8 minus X would be 16 minus 2X. Then we'll add 2X to both sides and get 5X is equal to 16. Divide by 5 and we get 16/5. Or that would be 3.2 feet. So our best placement would be when this is 3.2 feet this direction. So how long of wire does she need? Well, if this is 3.2 feet over here and this is 8, that means that this would be 4.8 feet right there, because 4.8 and 3.2 makes a total of 8 feet. And now we can use the Pythagorean Theorem to find out exactly how long this wire should be. Now remember, it should be less than 14 because this should be the best spot. So let's start right here. I'm going to do 6 squared plus 4.8 squared is equal to, I'll call that C, or I guess it really doesn't matter. And then over here, I'll do 3.2 squared times 4 squared plus 4 squared is equal to the other C, because we're doing the hypotenuse on both of those. And now we'll just go ahead and solve them out. So I get 36, 4.8 squared is 23.04. Combine these two together and I get 59.04. So C would be the square root of 59.04. On the other side, 3.2 squared ends up being 10.24 plus 16 equals C squared. Here we get 26.24. So C on that side would be the square root of 26.24. All right, let's plug it into our calculators and see what those two values are. So if I plug it into my calculator, 59.04, oops, forgot the square root. Dang it. So square root of 59.04 comes out to approximately 7.68. And over here, if I take the square root of 26.24, I get 5.12. Let's add those two numbers together. We saved it a little bit there. Here we said 14 feet was the best we could do, and that was better than this one because here we used 14.9 feet of wire. Here we used 14 feet of wire, and this looks like this is the best option. I could get away with doing 12.8 feet of wire if I put the sound system 3.2 feet away from the bottom of B. And there's our answer. So the shortest distance is always going to be where we can make proportional triangles. So we used our scale factor. We called this part x, and this one was just 8 minus whatever x is. And then we were able to do proportional triangles here to find out where the placement should be. And we found out that the best measurement would be 12.8 feet. That's how much of that diamond-plated wire we would need. And we just saved Laura some money. There you go. That's all I got. Math hard. See you guys later. Bye-bye.